Which of the following functions, when graphed, would have a constant rate of change and an x-intercept of -5? So constant rate of change, that's the first thing. That means our x value is not going to be changing based off of it. It's going to be constant. Like, doesn't matter what the number is, it's going to have a constant rate. So anything with an exponent is out right away, because those are nonlinear. Constant rate of change is just another word for linear. Or, in another way of saying slope, like a slope. Okay, so when we look at this, we have two choices. 2x minus 5 and 2x plus 10. We want an x-intercept of -5. To get an x-intercept, x-intercept means it crosses the x-axis. So if I were to give you a visual, this is my x-axis, y-axis, 1, 2, 3, 4, 5. That would be my -5. So we're going to just plug in numbers and see what we get. So let's try C first. F of x equals 2x minus 5. Well, since that's at 0, or it's at -5, 0, let's try to plug this in and see if it comes out with a 0 solution on both sides. So we plug in 2 times -5 minus 5 equals 0. As you can see, I plugged in, and I plug the 0 in. So when you plug in x, you should get a 0. Let's check if it works. As you can see, this doesn't equal out, so that's not going to be a solution. So let's try D real quick. And we need it to be at -5, 0. So we plug in our x, -5, and our entire function should equal out to be a 0. Oh, it's a plus 10, oops. As you can see, both sides are equal, so you're good to go. If you want, you could also do this another approach. You could graph them. And since it says constant rate of change, you could do it that way. But I think algebraically is the easiest way to represent it. So remember, x-intercept just means it crosses the x-axis at -5, 0.